All right, so with adding and subtracting rational expressions, first things first, a complex of fraction. You're going to love a definition for this. It's a fraction. It's a little weirder than that. With fractions, it's a fraction with fractions in the numerator, Numerator, and the denominator, All right, it's a fraction with fractions in it. So some of you will look at this and go, "Oh my gosh, this is the culmination of evil." That is an example of a complex fraction. All right, and it's actually easier to deal with than you might think, but that's what it is. Okay, and we'll deal with those towards the end of the lesson. We might get them to today, or we may do them tomorrow. But it's not that bad. But it's a fraction with fractions on top and bottom. All right, it's essentially it's a fraction with a fraction. It's kind of like a fraction. It's a hot pocket with a hot pocket. Your notes? There's more in the back, but I don't know what to tell you otherwise. All right, so here we go. Let's keep rolling. Adding and subtracting with like denominators. Okay, they wanted us to do this with like A, B's, and C's. But I think it's just easier to do this. If I've got 3/5 plus 4/5, that equals what? Please say that louder. 7/5. Thank you very much. You added the top. Did you do anything to the bottom? No. The subtraction's the same way. If I have 4/5 minus 3/5, what do you have? 1/5. We left the denominator alone because the denominator is just saying what type of thing are we counting. All right. The top part, the fractions, the way they work. If you haven't remembered this yet, the bottom is this is the type of thing we are counting. This is what we are counting. We are counting 7 of the fifths size. All right. So for like 1 through A, B, C, and D, we already have a common denominator. Okay. So when we combine these, what are we going to get on the top? 10. What are we going to get on bottom?
4x.
4x. Good. No one said 8. Cool? Now, can you reduce this?
Yes. No.
5.
Yeah, you can divide them both by what? 2. So 10 divided by 2 is 5. 4 divided by 2 is 2. And some of these vectors are like, it's 2 and 1 5 or 5x. Or no, whatever. No, it's 2 and 1 over 2x. Because they have to have a mixed number. Yeah, I don't care. Don't do that. I won't count it wrong if you do, but get in the habit of having the improper. Oh, they're talking about improper fractions. But anyways, so here we go. The next one. All right. So do we have the same denominator? No. Yes, I mean. So does the denominator change? That's a really good question, Daniel. Anyways, so the top. What is 2x minus 5?
-3.
No, it is. It is 2x minus 5. You cannot combine them. Exactly. They are different terms, so you just have to list them. Don't worry, you're not the only person to say -3 all day. All right? All right? What? Huh? Okay, I'm lost. All right, cool. Try C and D. Take, I don't know, 15 seconds. Do C and D real fast. That was creepy. I know, but it was still creepy. I know, so we got, I don't know, 3 over 3x squared, which is 1 over x squared. That's the first one. Because it said minus, not add.
That's on me.
That's all right. The bottom one, the second one is what, just 2x squared plus 2. Yeah, you do. X squared plus 1.
I leave it just as
If you leave it just as, okay, if you left it just as an x squared, this right here, is that x squared in the numerator or in the denominator?
Numerator.
It's on top. It's in the numerator. So to show that it's in bottom, you have to put the 1 over there. Cool? All right, this second one. How do we do on this one right here? We get it?
Good.
Cool. There's actually, we can take this one step further. We can actually take this one step further. Let me ask you something. Can I factor this top piece?
Yep.
What can you factor out? Or what can you divide out? A 2. So if I divide the first one by 2, what are you left with?
1. X squared.
X squared. Good. If you divide the second one by 2, you get a 1. And what's left on bottom? Does anybody see it yet? It's the same, so what can we do to them? We can cancel them out and go, hey, x squared plus 1 divided by x squared plus 1 is really a 1. So the answer is deuces. Okay? So that is how you reduce these type of fractions. Okay? You add up the top, and then if you can factor it and cancel something, you do. If you can't, well, then you don't. All right? But it's like sometimes you can, sometimes you can't. All right? How are we doing on the first page? Give me 5 and 1. 5, I got this form. Okay, 3 and 2, I'm lost. 1 save me. Sweet, turn the page. Let's keep going.
1.
All right, so here we go. Adding and subtracting with unlike denominators. Okay, yeah, I don't want to do this with letters again. Let's do 3/4 plus 2/5. Okay? Let's do those. Can you add those two fractions as they are right now?
No.
No. What do I need to multiply the first one by?
3. 6.
We're going for a common denominator, right? Good, you have to multiply it by 5. All right, what about the second one? What do I need to multiply the second one by? 4. Okay. So 3 times 5 is what? 15. What's 2 times 4? 8. Add them up, you get?
23.
What number goes on bottom?
Oh, just guessing. Let's go.
20.
Oh, 40. Oh, 20.
Yeah, because 5 times 4 is...
20 or 40?
4 times 5 is 20, and you don't have to add them up. You leave it the same. Cool? Again, that's third grade fractions. Okay? We're going to do the same type of thing, but with binomials. So I'm going to give you a list of goals. Goal number 1. Factor bottom. Factor the denominator. Okay? Step number 2. Get common denominator. I'm just say dom. Get a common denominator. That's goal number 2. All right. Goal number 3. General number 1. General number 3. General number 3. We're gonna multiply out the top and combine. And I'll tell you what I mean by that in a minute. We're going to multiply everything out in the top and combine our terms. Because at times we're going to have a binomial times a binomial. Multiply out and bring them together. And then last but not least, reduce. If possible. All right, so those are your overall steps here. We're going to factor the bottom. We're going to get a common denominator. And then we're going to multiply out the top and combine it. And then if we can factor and reduce, we'll do it. If we can't, you're done. Okay? So the fourth one may happen, the fourth one may not happen. All right? But you always got to be ready for it. So here we go. Letter A. Do we currently have a common denominator? No. So step 1 or goal 1, factor the bottom. If it's just a single term, do we play with it? No. Okay. What about the second one? To factor this one out, are we going to divide something out or are we going to put up the parentheses?
Divided by 3.
All right, we can divide it by 3. So if I divide it by 3, what are you left with?
X squared and 1.
Plus 1. Good. Everybody cool so far?
Yes.
All right, so here's what we're going to do. We are going to make sure both sides have every single piece. Okay? And here's what we're going to do. Here's how we're going to do that. What? Yeah, sure. I got 7 over 9x squared. Okay? Question. What does this denominator have over here that the first one is missing? And not just an x squared and
1.
x squared plus 1.
Let's go.
Because these are two different pieces. The parentheses are all or nothing. So it's missing an x squared plus 1. And just like the fraction up above, whatever you do on bottom, you have to do on top. Cool? And I'll scoot this up so people can see. What about over here? Is it missing anything else? Is it missing anything else from over here?
No.
No, good. Why is it not missing a 3?
It has a 9.
Because it has a 9. A 9 is a 3 times 3, right? So it's already got the 3. It doesn't need another one. Cool? All right, let's do the other side. Plus x over 3x squared plus 1. All right? And there's 1 right there. Question. What does the first one have that the second one needs? It's already got 1 3. Does it need another one?
Yep.
Yes, it does. It needs to have 2. The first one has 2, so the second one has to have 2 as well. What else does it need? What's up? What does this first fraction have that this second one doesn't in the denominator?
X squared? No.
It doesn't have an x squared. It's got the x squared plus 1, but is there an x squared?
No.
No, so it also needs an x squared. Part of the reason we did this problem is you need to differentiate the difference between, hey, this is one term, this is actually a different term. This is a different item. An x squared plus 1 is not the same as an x squared. Okay? You have to treat them as individuals. It's okay.
You're losing us.
Nah, I get this.
I know.
Okay.
Y'all get
I'll get you back by the end of the class. I promise you.
All right.
I'll get you back. All right, so that was goal number 2. Goal number 3. What does goal number 3 say? Multiply out the top and combine it. So I'm basically going to do it right above it. So just start distributing. So what's 7 times x squared?
7 x squared.
What's 7 times 1?
7.
Okay. Then the right side, it's all multiplication. So what's x times x squared?
2x squared.
X times x squared would be x to the third. Times 3 would be 3x cubed. So I just multiplied out the top, and I'll bring it together. I have a 3x cubed, I have a 7x squared, and I have a 7. All divided by 9x squared, x squared plus 1. All right. This is one of those times when I think this is a horrible first example.
Yes.
Yeah.
Partially because the answer is uglier than the beginning. All right. So here's the deal. We're going to do another one together, but by the end of the next one, I want you to say, is any individual piece that difficult? And kind of ask yourself that as you go along to the next one, okay? So here we go. Let's do the next one. Step 1. It says factor the bottom. Now, one thing I am going to do as well is this is a subtraction, right? So what I'm going to do is I'm going to distribute that negative and make it a plus problem. Okay? Now it's an addition problem. I just multiplied everything on top by that negative. If it was positive, it goes negative, negative becomes positive. So from here, let's factor the bottom. Can I divide anything out of this? Okay. And what's left behind? Cool. Daniel, put your phone away. All right, what about the next one? Can you divide anything out of that? No. Okay. But we can do this. What goes on the left? What multiplies to 3? 3 and 1 are your only options. What are their signs?
We add negative, no, negative and.
Yeah, they have to both be negative. To multiply to a positive, they have to both be negative. And they have to add up to a -4. So if you owe $3 and you owe $1, you now owe $4. Cool? So that's goal 1, we factor the bottom. Goal 2, get a common denominator. So here we go. I'm basically going to write out what we've got like this. 2x minus 1. And I'm going to give myself some space. Plus 2x plus 1 over x minus 3, x minus 1. I just literally copied everything down. Okay? And then I ask myself this question. What does this denominator have that is not over here? The x minus 3. It's got the -1, but it doesn't have the -3. So when you got to put the x minus 3 on top and on bottom. Because whatever you do to one side of the fraction, you got to do to the other. Cool? All right. What does the first one have that is missing over on the second one? The 2. It's got both of the binomials. It's missing the 2. So we'll multiply it by 2. Cool? Now we have a common denominator. You all right, Maria? Goal number 3, what does it say? Multiply the top out and combine. This is probably the most tedious part, but let's start. What is x times x?
X squared.
X squared. What is x times -3? What's 2 times x? What's 2 times -3? All right, let's go to this side. What is 2x times 2? What is 1 times 2? Okay, so there's the top. Let's combine everything. How many x squared do you have on top? 1. All right, add up your x's. How many do you have on top? There actually are 3. Which I personally I do the positive ones first. That's 4, 5, 6. -3 is 3. All right. How many units do you have? -4. All over 2 x minus 1 x minus 3. Cool. You starting to feel a little better about this?
Yep.
All right. So that is adding them together. The last step is reduce if you can. So let's do this. This is alone. So does anything multiply to -4 but add to 3? 4 and -1. So your two factors would be x minus 1 and 4. Because they multiply to the -4, add to the 3. And I'll just drag over the bottom.
And then it's going to be x plus 4 over 2x.
Good. We can cancel those out. And we've got x plus 4 over x 2 times x minus 3. But you don't have to multiply out the bottom, just leave it like that. You can write a 2x minus 6 if you want. All right, so here's the deal. This is where we got to back up and ask ourselves this question. Really, how hard was this? It's a lot to look at. I'm not going to deny that. All right? But so long as you keep yourself organized and go slow enough that you don't make dumb mistakes. So, like, I distributed the negative, not hard. I factored the bottom, not hard. I got the common denominator, that's this part in green. I added whatever I needed. Again, not hard.
Yeah, that's the hard part.
You think this is the hard? Some people do think this is the hard part, and I understand that. It just takes a minute before you can see it all. To me, the hardest part is multiplying this all out without making a dumb mistake, because I want to go so fast that I'll do, x times x is 4x squared. Or something stupid like that. You follow where I'm going? We combined it, and then we could factor and cancel. The hard part is not getting lost as you go. All right? But each step is not that bad. Okay? So here we go. We're gonna do 3 more. And we're gonna call it a day. We'll do the next page tomorrow. Okay? But I want you to walk me through them. So letter D. Step 1. Do we have a negative to distribute?
No.
No. All right. Are we gonna factor this one? No. Are we gonna factor this one? How?
3.
Divide by 3. Good.
B.
Yes, dividing by 3 is factoring. So if I divide by 3, what am I left with?
X is square.
3 squared.
Good. Cool?
Yo.
So we got a common denominator. I mean, we got a factored bottom, so we'll write that out. 1 over 3x squared. And then we've got plus x over 3x squared minus 4. And this doesn't want to pick up today. All right, let's add what we need. What does the first fraction need?
Minus 4. No.
Not just the minus 4, the
3x squared.
3x squared minus 4. It is the entire piece. Those binomials are all or nothing. Which, now that you put that up there, do you still need this 1? No. I mean, I'm not going to do anything to it, but you don't really need it. All right, what does the second fraction need?
3. No.
It's got the 3.
3x squared.
It needs the x squared. Good. They both have the 3, but they do not both have the x squared. All right. Do we have a common denominator now? This means yes, this means no.
Yes.
All right, cool.
Yep.
I just need some sort of, okay, we're talking. Fair enough. Really, is there anything to multiply out on the top?
Okay.
The only thing to multiply is this thing. X times x squared is x to the third. Is there anything to combine? No, you got an x cubed. You got a 3x squared. And you got a negative 4. So we got 3x squared, 3x squared minus 4. Cool? Now, you might be tempted at this point to think, oh, I know it multiplies to negative 4 and adds to 3. You're right, positive 4 and negative 1. But this is an x squared and an x cubed.
Yeah.
So this is actually a different beast.
Yeah.
We're actually done right here.
Yay.
Okay? If you did notice the negative 4 to 3, good for you. That's excellent. I'm glad you saw that. But in this case, we can't. All right, so all in all, how are we feeling about this? Give me 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. All right, sweet. Let's do 2 more. This is one of those days I feel like we just need to keep pushing them and keep doing them and keep doing them. Dig a rut in a little bit. All right, letter E. What are we going to do first?
Negative.
Strip the negative. Okay. So if I do it like this, right? Positive, that becomes positive, that becomes positive, that becomes negative, that becomes positive, right?
Yeah, right. Yeah.
I thought you didn't do it to the bottom.
Thank you so much. I'm glad somebody picked up on that. You do not do it to the bottom.
Yeah, that's right.
I think several of you were thinking that, but you were all like, huh? No, only do it at the top. Somebody was brave enough to say something. Okay, step 1. How do we factor the left side?
The bottom.
The butt cheeks.
All right, cool. The butt cheeks, exactly. Yes. Fill them in. Do the same thing with the right side. Factor them out real quick.
At least you remember.
I do remember.
Okay, then do it.
I got it.
I can't help but laugh at this one. I'm sorry. It's too easy. All right, so. Oh, we'll put it back up there in a minute. All right, so we got what? X, what, minus 2, and x minus 1, and we have a 2, x minus 2. Cool? All right, so let's copy everything down. 5x minus 1 over x minus 2, x minus 1, plus 2x plus 1 over, I'm literally just copying everything from above down. That's all I'm doing right now. The red is nothing new. All right, get yourself your common denominator. Jerry's Fun World. Do I have Carrie in here? Carrie Kristen?
Terry?
Oh, Terry. I'm Terry Christian, yes.
Terry, hey Terry.
All right, thank you. Bye, Terry. Have a wonderful day.
Oh, you.
I was like,
No,
I thought she was saying Carrie Tristan. And I'm like,
Yeah, I'm not shaking hands either.
what are you going to do? All right, what does the first fraction need?
2.
A 2.
Let me
So 2 on top, 2 on bottom. What does the second fraction need?
And then x minus 1.
Excellent. X minus 1, x minus 1. Cool. Later, man. All right, what do we do next?
How you know that it need a 2?
How do I know I needed a 2? Multiply at the top and combine. Good. Y'all go ahead and do that. Henry, what it is how did I know this needed a 2?
Yes.
Well, this has a 2 in the denominator and an x minus 2. Well, there's already an x minus 2. Do you see a 2 down here as well?
No.
So we need to add it. And whatever we put on bottom, we put on top.
Because if you add it in the bottom, you're gonna add it.
Exactly. To keep this, if we don't add it to the top as well, we now have a new fraction. By adding it to both, the value of the fraction is the same. It just looks different.
And why you put the x minus 1?
Same idea. This one has an x minus 2. They both have an x minus 2.
But you only
They both
check
have a
the bottom part?
Only have to check the bottom part because you got to get a common denominator.
Oh.
Just like adding regular fractions, you just get a common denominator and add. All right, so multiply at the top. All right. Did you get a 2, a 9, and a negative 3?
And the bottom, how you
Yeah.
add it up, the bottom part?
The bottom part?
Yeah.
Squared.
Yeah.
What x squared?
Yeah.
I don't know what you're talking about. Henry, basically what it is this is the same as those two. Like, we both have a 2, we both have an x minus 1, we both have an x minus 2. Both have a 2, x minus 1, x minus 2.
Oh.
Well, the denominator, once you get that common denominator, it stays the same. All right? So the last question we have to ask is, are we done or can we reduce? All right? Which most of us would think, hey, nothing multiplies to negative 3 but adds to 9. But what is different about this one? It has a 2 out front. How do I factor that in? Well, you got to go one more step beyond. Here's what I mean. Let me get a different color. What is 2 times negative 3? Negative 6. So is there anything that multiplies? So instead of negative 3, what multiplies to negative 6 and adds to 9? So 6 times 1. Can you get a 6 and a 1 to add to 9?
No.
Okay. 3 times 2. Can a 3 times 2 add up to 9? No. Anything else multiplies to 6?
3. Check.
3 times 2 and 6 times 1, that's it? So this is not factorable. Okay? That's a quick and easy way to know if you can't go any further. Rather than just pulling out your parentheses and just trying 14 things and freaking out. Like, this doesn't work! Alright, so multiply the outsides and what multiplies to that adds to the middle. Here's my point. Multiply the outside, since you had a number out front, which is negative 6, and think what multiplies to negative 6, but adds to the 9. And if you don't get anything, you can't go any further. Okay? If you do get something, yeah, then go ahead and set up your parentheses, 2x and x, and start working it out. But if you get nothing, then you're done. It cannot be factored. This cannot be reduced. That is your answer. All right. I thought he had done something over there. All right, last one. Letter F. Like I said, we're just going to keep doing this till we're done. All right. Do we have to distribute a negative?
No.
All right, factor the bottom. I'll give you your sentence stems.
The lesson is up there.
Oh, yeah, I did
What if I say that? Yeah, but you didn't, so.
He sucks. Okay.
What?
So for the first two, what'd you get?
X plus.
X plus 3 and x minus 4.
Yes. And for the second one, you got what out front?
12.
12. And on the inside, you got?
X minus 4.
Sweet. All right, let's get that common denominator. So we got x over x plus 3, x minus 4, plus 5 over 12, x minus 4. All right, take a second. Get that common denominator.
Now you
Cool. Did you get 17x plus 15?
yes.
Sweet. Can you factor the top at all?
No.
No. Nothing to divide out? No x squares to deal with?
No.
So is there? Can we go further or are we done?
We're done.
We are done. Stick a fork in us.